Okay, so welcome to a brand new chapter for discussion of the answering session, where we are going to discuss chapter 3, periodic table periodicity. Yeah? So hopefully you all are ready with the solutions and we're ready to accept the explanation that I'm offering for you. Okay, so with that station, let's begin our lesson. Okay, so section A, objective question number 1 sounds like this. Among which of the following pair of the period 2 element is the difference of the boiling point are the greatest in here? So you need to understand what is the melting point, boiling point. So in order for you to understand, I apply to you the tables. So in here, it seems that the one with the largest difference in here will be obviously from carbon to nitrogen in here. Okay, so they have the greatest difference of energy. So therefore, the answer for question number 1 is boy B. Okay, so that is for number 1. Okay, so teacher, do we have to memorize this melting point? Don't have to really exactly memorize the value, but at least memorize the pattern of how the graph will looks like, because usually the value will be given to you in the questions. Okay, so just try your best to remember the pattern of the graph, how it looks like. Okay, so that is for question number 1. Okay, then we have question number 2. The graph below shows the variation of the 6 first successive ionization energy of an element in the periodic tables. So this is the first 6 successive ionization energy. Which of the following best explain the large gaps between the third and the fourth ionization energy? So why is there a large gap between the third and fourth? So definitely this is due to the fourth electron is removed from an inner shell. Okay, so in here, so electron is removed from the inner shell. Okay, so that is why which has an octet configuration, and which is the reason why it need a higher energy to remove it. Okay, so the best answer in here will be number D. Okay. Okay, so that is how you solve for question number 2. Immediately we go to question number 3. The successive ionization energy in kilojoule per mole of an element in the periodic tables are given below. 653 first ionization energy, 1710, 2930, 4090, 5460, 9410, 11300, and so on. Okay, so in here you need to find where is the large gaps that happens in here. So just don't have to calculate exactly where the large difference of the value, just an estimation of the value is enough. For example, the difference between the first and second 653 to 1710 is somewhere between 1047. Okay, 1710 to 2930 is somewhere in between 1220. Yeah? 2930 to 4090 is 1060. 1160, sorry, 1160. 4090 to 5460 will be 1270. And then 5460 to 9410 will be somewhere around 3950. Okay, and then suddenly 9410 to 1130, it dropped back to 1720. Yeah? Okay, so you see the gap suddenly becomes small back. So in another word, the one with the large energy gaps in here should occur in between the 1, 2, 3, 4, 5, and 6. Okay, so in here you take the 1, and then you calculate how many electrons has been removed so far. So in here it seems that there are 5 electrons that have been removed. So it is from group 15. Okay, so the answer is donkey D. Okay, so that is for question number 3. Okay, immediately we go to question number 4. First successive ionization energy of metal P and metal Q are given in the table below. So that is for P and Q. Which of the following are correct regarding to the element P and Q? Okay, so it is a metal. Don't forget that this is a metal. This is a metal. So the facts that says that P and Q, when P is a lower ionization energy, while Q has a higher ionization energy, That means in terms of position, if you still remember the trend of the periodic tables, so it says that in the trends of the periodic table, ionization energy increase. Okay, so when you have a higher ionization energy than the other one, so Q must be more left compared to P. Sorry, Q must be more right compared to P. Now, it does not necessarily group 1, group 2, but there is a possibility because they are all metals, isn't it? Okay, okay. So which of the following statements are correct in regard of P and Q? Number one, metal P and Q are from group 1 and group 2 respectively. So this is possible because Q has a higher ionization energy than P. Okay. Number two, size of an atom P is larger than the Q. So when you have first group elements, will always be greater than the second group. So number two is also correct. Okay, so number three, simple ion has a higher charge than simple ion of P. So Q will form a +2, while P will form a +1. So number three is correct. And then number four, first and second ionization energy arise from the elimination of P and Q from S orbital. Now, this is only true for Q because Q is from group 2. So the first two ionization energy is removed from NS2. However, for the after you remove because it is NS1, isn't it? So after you remove the first electron from the P, the next electron is removed from the first electron is removed from the S orbital, the next electron is removed from the P orbital. So that is why you need an exceptionally high second ionization energy, okay, compared to the other. So in here, the section number 4 is wrong. Okay, so the best answer in here is 1, 2, and 3. A is the answer. Okay, so with that, that is how you answer for question number 4. Immediately we go to question number 5. Which of the following statement is true regarding to the oxides of the element in the period tree from sodium to chlorine? A. Sodium oxide is the strongest base in the period tree since sodium is the most electropositive metal, which is actually true. Okay. Going across period tree, the properties of the oxide changes from basic to acidic due to the increase of electronegativity. Okay. Now there is two parts of the statement. First is the property of the element changes from basic to acid, which is actually true. However, does it have anything to do with the electronegativity? No. So it is due to the covalency. Okay, covalency and electronegativity are two different things. So we cannot say the whole sentence is B is correct. So B is not the best answer. And then C, aluminium oxide is amphoteric since it is from group 13. Is it because it is from group 13 that is why it is amphoteric? No. Aluminium oxide is amphoteric because it is an ionic compound with high covalent characteristic. So C is wrong. And then D, chlorine reacts with oxygen to form the stronger acids, which is wrong because chlorine does not directly react with oxygen. The chlorine oxide is prepared via other chemical reactions. So D is also wrong. So the best answer in here will be A. Okay, so that is how you solve for question number 5. Immediately we go to question number 6. An element X has the valence electron of 2s2 Which of the following graphs shows the correct successive ionization energy here? So when you have 2s2 it is from group 14. And when it's from group 14, then you must have 4 valence electrons at the end there. So here you got 3, so A is not the answer. Here you got 2, B is not the answer. Here you got 4, which is the correct answer. And the difference between the log ionization energy in here, they shouldn't be this much far. This is too far. Okay, this is too far to separate between NP then NS. Okay, so too far already. So the best answer in here is still C. Okay, so that is how you answer question number 6. Immediately we go to question number 7. Dmitry Mendeleev arranged the elements in the periodic table based on the what? It is based on the increasing in the atomic mass of the element involved. So the best answer in here will be C. Okay, number 8. Going across period 3 from sodium to chlorine in the periodic table. Number 1. Electronegativity of the element decrease. No, when going across the period, electronegativity, electron affinity, ionization energy increase when going across period. So A is wrong. B, ionization energy decrease. If A is wrong, B is also automatically wrong. C, the standard electric potential of the element increased. So this is true. Why we said it's true? Because sodium is negative 2.71, magnesium 2.38, aluminium negative 1.66, then chlorine positive 1.36. So the value has become increasingly positive in here. Okay, so the answer in here will be C. So from the strength of the element as oxidizing agent increases, so it's not increased. So it's not to say strength of elements. If today we are talking about this ions, okay, ion. So the statement, the strength of the element, the strength of the ion increase as oxidizing agent increase. Yes, I would say it's a yes. What do I mean in here? What do we mean here is, for example, if Na plus plus E minus give Na, E naught is equals to negative 2.71, and then Mg2 plus plus 2E minus. Anyone accidentally open the mic? Yeah. Thank you. Okay. So Al3 plus plus 3 minus Al. Okay, so in terms of reducing strength, okay, so in terms of reducing strength, so reducing agent is decrease. Okay. However, if we think from the other way around, if you look from this angle, then the strength as oxidizing agent, strength as oxidizing agent increase. Okay, because it becomes less negative. So that's why I said if we are talking about the metal ion, then it is correct. In here, the strength of metal ion. Okay. So if they change the statement to the strength of metal ion as oxidizing agent increase, then the answer D is correct. But now it's mentioned the strength of element, not metal ion, so it's not correct. So the answer, the best answer in here will still be C. Sorry, C. Okay, so with that, that is how we solve for question number 8. Then we goes to question number 9. Which of the following elements of the period 3, sodium chlorine, in the periodic table forms an oxide with the highest oxidation state? Okay, so here you can form sulfur, so automatically sulfur. Aluminium only form Al2O3 with a +3. Si form SiO2 at +4. Phosphorus form P4O6 and P4O10, which is +4 and +3 and +5 respectively. Sulfur form SO2 and SO3 respectively. So in here, the best one that will represent the more is sulfur. Okay. Number 10, oxide ion, chloride ion, sodium ion, magnesium ion, and aluminium ions are simple ions which are isoelectronic. Which sequence shows the order of decreasing ionic radius? Decreasing. So if decreasing means that it becomes larger and larger. So you have to bear in mind that in terms of number of proton, because they are all isoelectronic. So when they are all isoelectronic, screening effect is the same. So when screening effect is the same, what will influence the effective nuclear charge? It will be the atom number on number of proton. So given to you, oxygen is 8, chlorine is 17, sodium is 11, magnesium is 12, and then aluminium is 13. Okay, so the one which has the largest ionic radius supposedly to be the largest ionic radius supposedly to be the this oh, okay, I think I made a mistake here. It's supposed to be F minus. Yeah, right. So fluoride is 9. Okay, so whatever it is. So the one that has the largest atomic radius will be the one with the lowest atomic number, which is oxygen. Oxygen. So answer is very obviously now in A. But let's have a look at the following solution. So followed by chloride ion, sodium ion, magnesium ion, and finally aluminum ion. Okay, so the best answer in here will be okay. So that is how you solve for question number 10. Okay, finishing number 10, then we immediately goes to question number 11. Okay, so graph below shows the variation of the first 8 successive ionization energy of element A in the periodic table. Which of the following statement is not true? So we are looking for not true now. So this is the large brackets. So this is the period, whatever period. If this is period n, then this one will be period n minus 1 or even n minus 2. Okay, so that will be how the development goes by. Okay. Okay, so which of the following statement is not true? So in here, you can see that the number of electrons in here, as you can see, there are 5 valence electrons in the outermost shell. 5 valence electrons in the outermost shell. So when it is 5 electrons, so it is Ns2, Np3, correct? Number 2, the large gas indicates the electron is removed from an inner shell, which is also correct. The effective nuclear charge of A remains the same throughout the successive ionization energy, which is wrong. If they say nuclear charge, yes, because the proton, which is the one with the smaller, okay, they will also have the outermost electron. So you remove first all the outermost electron, only then you can remove from the inner. Okay, so B is correct. C. Effective nuclear charge A remain the same. No, effective nuclear charge eventually increase. Okay? And finally, the ionization of A is higher than the element next to it, which is true, because usually if you remove 5 electrons, you are from group 15. So when you are from group 15, you have the valence electron of Ns2, Np3, which is the half-field p orbital. So half-field p orbital has extra stability, which makes the ionization energy of the A is higher than that of the element next to it. Okay, so the best answer in here will be C and D. Okay? C, because you're looking for not true, sorry, C. Okay, so this is number 11. Then we continue with number 12. The following graph shows the variations of the physical properties of period 3 from sodium to argon. What is the physical property? So this is very, very obviously, if you look at the graph closely, this is trying to tell you the melting point of the elements. Okay. Okay, so that is for number 12. So this is a melting point trend. This is a melting point trend. Okay, number 13. Which of the following statement is true of the periodic table? So it is built based on the nuclear number, which is wrong. So there are 8 groups in the periodic table, which is also wrong. Elements are divided into 5 blocks. No, it's only 4 blocks, SPDF. And finally, there are 7 periods in the periodic table, which is true. Okay, so let's say in terms of group 1, you have hydrogen, lithium, sodium, sodium, lithium, okay, and so forth. Okay. Okay, so with that, that is how you answer for question number 13. Okay, immediately we go to question number 14. The sequence of the reactions for oxide X is shown in the scheme diagram below. So you have X plus NaOH give Y, so Y react with Fe2 plus to give yellow solution. So when you react with Fe2 plus to give a yellow solution, so it will indicate that some of the iron 3 plus has been formed from iron 2 plus. So that's why you form a yellow color solution, which indicates that iron 2 plus has already changed to iron 3 plus. Okay, so aluminum oxide is amphoteric while ClO is acidic, which react with the sodium hydroxide. However, ClO2 react with NaOH to form ClO minus with Fe2 plus, which is green, will be able to oxidize to become Fe3 plus, which is a yellow solution. Okay, okay, so that is how you solve for question number 14. Immediately we move to the next question, number 15, shall we? So the graph below shows the variation in three physical properties of the element in the periodic table. Now, as a student, you must be very good and very sharp in telling. You see this pattern, definitely is the boiling point. Okay, is the boiling point. Boiling point of the element. As for number two, the graph showing a decreasing trend. So what decrease when going down to the group? You can have atomic radius. You can have this other than atomic radius. What else is decreasing? Oh, ionization energy, electron affinity. Then our this electronegativity is also showing negative trend. And last but not least, this one is obviously ionization energy. Okay, so the best answer in here is number B, melting point, atomic radius, 10% ionization energy. Okay, so with that, that is for question number 15. Huh? Then we goes for question number 16. Which of the with the reference of the periodic table, which of the following has the greatest ionic radius? So first of all, you'll find which one has the highest atomic number. So the one with the highest atomic number in here is aluminium. Okay, so aluminium will expected to have smaller than Na. Okay, so when it is coming to this one, so among them, F minus and O2 minus has a lower charge density than this. That's not charge density, mass number, proton number than sodium. So we expected the F minus and O2 minus has a larger atomic radius or ionic radius when compared to sodium ion. So that is how you answer for question number 16. So the answer is 1 and 4. So B is the answer. Number 17, which of the following properties of the elements in period 2 and period 3 of the periodic table changes periodically? Number 1, electronegativity decrease, which is yes. Okay, and then the conductivity increase from sodium to aluminium sodium to silicon, then decrease back, so no proper trend. And then in terms of enthalpy vaporization, it is similar to that of the conductivity. So 2 and 3 are both wrong. And electronegativity, electron affinity, ionization energy, all of them decrease when going down to the group. Okay, so the best answer in here will be. Okay, then we have number 18. The first four ionization energy of the elements W, X, Y, Z are shown below. So which statement about W, X, Y, Z is true? Okay, so let's together try our best to deduce which group does it belongs to. Okay, if you look carefully about the gaps in here. So this one, some gaps between 1,263. Yeah? So these two will difference about 980. Sorry, 920. Then 27640 minus off by 1160, it should be 8,000 plus. So in another word, W is from group 13. Okay, as for X, 4001, if you already look up just now, we did mention that in between 418 and 307, so this is around 2,000 plus. Okay. So this one is back again to another 1,530. Okay, and then this one to this one is somewhere in between 1,260. So in here, since Y has the largest gaps in here, so in another word, X is from group 1. Okay, and last but not least, Y. So which group does it belongs to? So if you look carefully, it looks the widest gaps in between the second and third. Therefore, Y is from group 3. Group 2, sorry. Okay, so with that, that is how you deduce the value X, Y, Z. A. Which of the following statements about W, X, Y, Z are true? 1. Z is more electronegative than X, which is not true because Okay, because Z is from group 1, okay, while WXY is not from group 1, so it is the least electronegative, not more, it's less electronegative. So A1 is wrong. Number 2, melting point of the Z because it's expected for group 1. Okay, so it's higher than that oxide value. So since you have 2 different electronegativity, so therefore cannot compare just like that. And then number 3, enthalpy of vaporization of X is higher, so it cannot ask the same the type of question. Okay, and then finally, oxide of the X is more basic than oxide of W, which is also not true. Okay. Okay, so the best answer in here will be 1, 2, and 4. So the answer in here will be B. Okay, so finishing number 18, we go to number 19. Okay, so PQRS are elements in the period tree of the periodic tables. The symbol and physical and chemical properties of the oxide of this element are shown below. So oxide of element PQRS, physical, gas, solid, solid, solid. Solubility in water, P very soluble, QR insoluble, and then S is soluble. In terms of acidity, PQ are acidic, R and S are amphoteric and basic respectively. Which order of the electron arrangement for the correct value of elements in here? So you want to deduce which one is correct, which one is not, okay? Okay, so in here, it seems that because based on acidity, S is the most left because it is the basic oxide. So followed by R, which is less acidic, in contrast with the this ionization energy values. Okay, so you can go back and search by yourself. Okay, so P and Q are acidic oxide. However, only phosphorus oxide and silicon oxide, solid oxide, with SO3 and the SO2 gases. So the best one is still A, the answer. Okay, okay, so that will be question number 20. Then for 21, an oxide J has the melting point of boiling point of 20-30 degrees Celsius, which following in aqueous solution is hydroxide, but not in water and acidic. So oxide J is, so this is a very obvious question. Since it is an oxide with high melting point, which can react with base, but not acid or dissolve in base. So therefore, it is an acidic oxide which has a giant covalent structure. So in here, it is SiO2. Okay. Okay, then the answer in here will be C. Number 22, which statement about X plus, Na plus, OZ minus are correct? So, so in here, you expect that F ion, Na plus ion, and O2 minus ion are isoelectronic since they have the same number of electrons, hence the same screening effect. Though because they have a different proton number, therefore F ion, Na ion, and O2 ion has the same this what we so called as the screening effect. Okay, so that is why they have different character, they have different chemical properties. Okay, so the fact that F plus, Na plus, and O2 minus are isoelectronic is correct. F minus, Na plus, and O2 minus have the same screening effect, which is correct because we are under this one, same number of electrons. Okay. And then number 4, F minus, Na plus, and O2 minus has the same chemical properties, which is wrong. Okay, so the best answer in here is 1 and 3 only correct. Okay, so there you have, I have for you 22 objective questions for the time being. So we are going to continue our objective in our next lesson, shall we? Okay, so with that, I finished the first part of the chapter 3. We will continue on next week.